Hey guys, I just wanted to make a quick practice problem video for 9.5 area of sectors and segments. First couple problems, you just need to draw pictures, so don't overthink these. Just do what they ask. Draw a circle P with radius of 5 meters. So let's start with that. There's my 5 meters and a sector bounded by a 60-degree minor arc. Okay, so just going to eyeball 60 degrees, and I'm going to say that this arc out here is 60 degrees. That's it. All right, moving on. I think you guys are going to find that area of a sector is pretty easy, whereas area of segments are a little bit more difficult. So let's start out by just writing out the formula, because I think that helps. So area of a sector is theta over 360. Remember, theta is just the Greek letter that we use. It could be x, it doesn't matter. It's just whatever the degree that you're given. So for this problem, it's 135. It's just going to go there, okay? Times the formula for the whole circle. So, which is, of course, just 2, not 2, pi times radius squared. Okay, so essentially this part of the equation is giving you the whole area. And then this part of the formula is just giving you whatever fraction of the total area that you need to find. All right, so really, the reason why I think these are so easy is really you're only looking for two things, whatever the theta value is and whatever the radius is. So for this case, it's 135 and the radius is 15, and that's it. So just plug them in to the formula where they need to be, and your calculator can do the rest. So this is 135 over 360 times pi times 15 squared. And I'll pull up my calculator here. So I can just type this whole thing into my calculator. Hit the fraction button, 135, go down, hit 360. Make sure you get out of the denominator by hitting this arrow key. And now you can do, times pi. You can do 3.14. You can do pi. Doesn't really matter. I'm going to use pi. Let's see, what are the... Okay, so for the directions here, we want rounded to the nearest tenth here. So you could certainly use 3.14. That would be fine. And then times the radius squared. So I'm going to do 15. Close the parentheses. Hit this arrow key. I can raise it to whatever power I want. I'm going to square it. Press enter. All right, now so this is a very exact answer. That's a pretty ugly answer. And it's not the answer we want because the directions 4, 3, and 4 say round to the nearest tenth. So I'm going to hit this double arrow key button. There we go. So I'm looking at 165.07. So I'll just call this 165.1. 165. When is 265? 265. 265.1, and this is miles, and we are figuring out an area, so this has to be miles squared. All right, so 4, 5, it's all the same thing. You're just changing two different values. You're using the same formula, but the theta value is 195 for this problem, and the radius is 10. Okay, plug them into the formula, have your calculator do the rest. 6 and 7, really same exact thing, except you're going to have kind of that ugly answer that I got, before I hit that double arrow key right here. That 675 pi over 8. That's the exact answer. So really, those are pretty basic problems. Segments is where it gets a little bit more interesting. So again, to figure out segments, we need to figure out the area of this sector, right? And then we subtract out the area of this triangle, and then what I'm left with is just this piece right here, which is the segment. All right, and some of these are a lot easier than others. So for number 9, if the radius is 5 for this circle, the radius is 5, that also means that for this triangle, it is my base, and it's the same here. So this is also the radius. So my height is also 5. So this one's pretty easy. You figure out the area of the sector, which we just did for problems 1 through 8, and then you take that value and you subtract the area of the triangle. So for this one, it would be 1/2 times base times height. So you're going to do 1/2 times 5 times 5. Whatever you get for this, well, that's going to be 12.5. You're going to take the area of the sector and subtract 12.5, and then you'll have just this piece here. All right, so some of these are a little bit easier than others. Number 10, I think I'll go in number 10 a little bit more in depth. So first thing I want to do is figure out the area of the sector. Okay, not the segment, which is what we're acting for, the sector. So that's all of this and the gray part. Okay, so and that's what we were doing on the front page. So that is bad theta. That's theta over 360 times pi times radius squared. So my theta is 150 and my radius is 6. So now I can substitute those into our formula. So 150 over 360 times pi times the radius, which is 6 squared. And let's get our calculator out. All right, so fraction button, large screen, 150, get into the denominator, over 360 times pi times 6 squared. Press enter, we get 15 pi. I want a decimal answer to the nearest tenth, so I'm going to hit the double arrow key, and I get 47.12, so we'll just call that 47.1. So again, this is area of the sector. So area of the sector is equal to 47.1. And now what we need to do is subtract the area of the triangle. Okay, so we're going to subtract this. All right. So now I'm going to go ahead and kind of draw a bigger version of this. Here's just a zoom in of this angle right here. Okay, so that's this angle, right? I'm just zoomed in on this triangle. So if this is, we know that this is 6 and this is 150, okay? But to figure out the area of this triangle, we need the base and we need the height. And the height we can draw in right in here. So if we draw the height in here, this does two things. This creates a right angle. So now I have two right triangles. And it also took our 150-degree angle and cut it in half. So now this is 75 degrees. Okay, so now what we have here is we have an angle measure and we have a side length. So now if we have those two, we can use our SOHCAHTOA and we can figure out our base and our height. So for this one here, we need to figure out this value and this value. Okay, so let's go ahead and label our sides. So across from the right angle is our hypotenuse. Okay, and so we're comparing in terms of this 75-degree angle. So in terms of this angle, this side length here, our height would be next to it, but not the hypotenuse. So next to just is the same thing as adjacent. So this is our adjacent side, and then the side that's across from this angle is going to be our opposite. Okay, so we're going to have to use two different ratios to figure out our two different side lengths. So let's start with our base. Actually, let's do our height. Let's try to figure out our height. Okay, so our height, and again, this is not to scale because this one looks pretty small here, and I zoomed in. So I'm doing what I know and what I need to know, and I know the hypotenuse, and I need to know the adjacent. So that's A and H. So I know I need to use cosine. So I'm going to set this up as the cosine of 75 is equal to x over 6. And now I multiply by 6 on both sides. Pull your calculator up for this. 6 times cosine of 75 is a pretty ugly answer. Definitely want a decimal equivalent for that. 1.55, let's just call that 1.6. So x is equal to 1.6. And again, this is going to be our height. So I'm going to change this x to an h to remind me that this is my height. All right. And now I need to figure out this x value, which is going to be half of my triangle's base. All right. So what I know is the hypotenuse is 6, and I need to know the opposite. So that's O and H. So I'm going to use sine, right? So OH. So the sine of 75 is equal to, same thing, x over 6, because it's O over H. I solve this one the same way. I multiply by 6 on both sides. Oops. Pulled up the wrong thing. There we go. Clear that out. I'm doing 6 times the sine of 75. Again, pretty ugly answer. Double arrow. Okay, let's just call that 5.8. All right. So now this here, we get x is equal to 5.8. Now, this value here, we just figured out that this is 5.8. This right triangle. So we just figured out this triangle, right? But we cut this triangle in half, so we know that this piece and this piece are both 5.8. So we need to double that. So let's just go to our calculator again, do 5.8 times 2, or you can do 5.8 plus 5.8, either one. We get 11.6. All right, so now I'm going to actually, so if this is x is 5.8, I'm going to put it as my base is 11.6. All right, so now I'm going to take my height and my base and plug it into my formula for a triangle, which is area of a triangle is equal to 1/2 times base times height. All right, and I know my base and height, so I'm just going to plug them in. Area is equal to 1/2 times 1.6 times 11.6. And again, pull up our calculator. Whoops. That's what I want to do. There we go. Let's move this over so we can see it. Fraction button, 1/2 times 1.6 times 11.6 equals 9.28. So there we go. My area of the triangle is 9.28. We said round to the nearest 10, so let's call this 9.3. So now, last thing we need to do is subtract the area of the triangle from the area of the sector, and you have your answer. So, clear. 47.1 minus, oops, didn't get the 0.1. 47.1 minus 9.3, we get 37.8. 37.8, and this is going to be feet. Again, this is area, so it's still going to be squared. And this is how we get area of a segment. All right. So guys, I know this is a lot. I know this was a pretty tough problem, but you really have had a few days last week to work on this, and you have all week to work on pretty much just 1, 2, 3 problems like this. So take your time on this, give them a shot. If you still need help, please come to me either at Google Meet or have your advisor call me down to your room. I will help you with each one of these problems. Just take your time. I know you can do it. There are a lot of steps, but you can do it. So good luck.